Assalamualaikum warahmatullahi wabarakatuh. So in this video I'm going to talk about the idea of a Venn diagram in representing the relationship between sets. Okay, so Venn diagram is sometimes known as primary diagram or set diagram or logic diagram, and it basically demonstrates the relations between a finite collection of different sets. And normally these elements are usually depicted as points. So here is an example of a Venn diagram, and this is the universal set. So the box outside here is the universal set. So this is the rectangle. It envelopes the closed curves, and this is known as the universal set. We use this symbol, or if you want, you can use an easier symbol, which is just denoted by U. So U is the universal set, and it is given by this rectangle here. So the rectangle here is a must, okay, to depict the universal set. Now, elements of the sets given are depicted as points. For example, this is the first set, odd numbers. So the set here is given by a circle. So this is odd numbers. And all the elements in this set should be depicted by points. And so maybe I just add, this is element 1, 2, and so on. So these are the way to represent the sets, the elements in that set. Yeah. So this is the set of odd numbers. Now, if let's say you have another set, so another set here is another circle. So this is another set given here, and this is the set that contains numbers that are greater than 10. So we have numbers such as 11, 13, 15, 17, 19. This is 12. So these are the elements in the particular set, which is numbers that are greater than 10. So since the universal set here is defined as numbers from 1 to 20, you will see that outside of the circles here will be elements that don't belong in either odd numbers or numbers greater than 10. So 2 is not odd number, 4 is also not odd number, and it is also not a number that is greater than 10. So that will be outside of the circle, and it is going to be outside here. So these are the elements that don't belong in either this set or that particular set. So this is an example of a Venn diagram where clearly you have a rectangle outside here to represent the universal set. And then when you have different kind of sets are usually depicted as closed curves, usually circles. But sometimes you will also see rectangles being used to depict sets. It doesn't really matter. Okay. Right, let's move on to the next slide here. So here is an example of a Venn diagram to depict that B is a subset of A. So here let's think of some example. For example, let's say we have a universal set, which is a number which consists of numbers between 1, 2, 3 in that manner until 20. So universal set contains all these elements. And let's say you have set A. So here we've got set A maybe consists of elements such as even numbers from this universal set. So here it could be 2, 4, 6 until 20. So this is a set with even numbers. And if let's say I have another set, which is set B. B here is a subset of A, so we know that all elements in B must be in A. So maybe B is just the even numbers from 1 to 10. So we have 2, 4, 6, 8, and 10. So clearly all the elements in B are given in A. Okay, so B is a subset of A. So this is one example to demonstrate the idea of using Venn diagram to depict the situation where B is a subset of A. So this one, so B is a subset of A, so B will be inside. The whole set B here is going to be inside set A. Okay. Now let's move on to the next example here where we have a Venn diagram that depicts two sets that are disjoint. Okay, so let's think of an example here. Let's say I have a universal set. So a universal set which contains numbers from 1, 2, 3, 4 until 20. And let's say I have set A. So set A here is the odd numbers from 1 to 20. So we have 1, 3, 5, and so on until 19. So that's odd numbers. Now let's say we have another set which is set B. So B is the set of even numbers from 1 to 20. So we'll begin with 2, 4, 6 until 20. And clearly we can see that set A and set B are disjoint because they don't have the same elements. They don't share the same elements, so they are disjoint. They don't have anything in common. So we will represent them as such. So set A is somewhere here. It's clearly not overlapping, and set B is somewhere else altogether. They don't have any common elements, so they are pretty much separated. Okay. Now let's look at the next idea, which is a complement of a set A. So complement of a set A refers to all the elements that are not in A. So the elements here are not in A, and it is usually denoted with this symbol. So this is the complement of set A. So we have C at the top part here. So this is the complement of a set A, or sometimes we use A bar to denote the complement of a set, or sometimes A prime. Okay, so if you use a Venn diagram to depict the idea of a complementary events or complementary set, then it looks like this. So we have set A. So set A. So we've got elements in set A. And if you want to talk about the complement of a set A, complement of a set A is denoted by A prime, and it refers to all the elements that are not in A. So all the elements that are not in A must be outside of A. So these are all the elements that are not in A. So we call it A prime as a complement of a set A. Yeah. So now let's imagine the universe is the set of integers from 1 to 100. So universe is the set of integers from 1 to 100. It could be 1, 2, 3 until 100. And A is defined as the set of odd numbers. So A is defined as a set of odd numbers, which means A will take values such as 1, 3, 5 until 99. So what is the complement of A? Complement of A are the elements that are not in A. So we can think of the complement of A is A prime, and A prime are the elements that are not in A. So it will be 2, 4, 6, and it continues in this pattern until 100. Okay, so that is one way of doing it. We can say that the complement of A is 2, 4, 6 until 100. So that is roster method. Okay, you write a set in terms of roster method, or if you want, you can write the set in terms of a builder notation. So you give a some sort of a statement here. So another possible answer to that is you can write down the complement of A is some values of x here, where x here is even number from 1 to 100. So this is in terms of set builder notation. So either way is fine really, okay? Alright, I think that's all for now, and I will continue in the next video, and I will be talking about the union and the intersection of sets. Thank you very much for watching.